Today we are going to do section 1.5, combinations of functions. By the end of this, we'll be able to add, subtract, multiply, divide, and do compositions of functions. So our very first one here, oops, let me scroll down quite that far. We're given f of x as 1 over x and g of x is x over x plus 1. These are two functions. We're going to do some basic operations to them. So the first one is part A there is stated as f plus g of x. We're really just adding function f and function g. So we're literally doing 1 plus x, whoops, plus x over x plus 1. Okay, and just we know about that, this really isn't done. We need to get a common denominator. And so this is something way back from algebra where you had rational expressions and rational functions, and getting a common denominator here, we've got to decide what it is first. So we actually need both denominators, x and x plus 1. So we're going to need to multiply this one by x plus 1 on both top and bottom. Sorry, it's not super clear using my finger here. And this one we're going to need to multiply by x on both the top and bottom because that's going to get things to be the same as far as the denominators. So overall then, we're going to have as our final result here that this is going to end up being x plus 1 plus x squared all over our common denominator of x times x plus 1. Look a little better with the plus sign too. So then we can rearrange this, but honestly, that's basically our answer. Here, let me make that look a little better right there. I'll make that a plus sign so it doesn't look quite so bad. Probably we should have the x squared first, then the x and the 1, but really this is our answer overall here. There's nothing more we can simplify. If I go to try to factor anything, it's not going to work out right. So that's really it. And sometimes they're going to be messy like this. Okay, so for part B then, where it says f plus g of 1, we can do one of two things. We just found f plus g of x over here circled in red. So we can simply plug 1 in for x, since we already have that result. If we plug in 1 for x, we're going to get 1 plus 1 plus 1 squared is going to be 1 all over 1 times 1 plus 1. There's just a lot of 1's going on there. And so if we do all of that, we're going to end up with 3 on the top, 2 on the bottom. So 3/2 is going to be our final answer, or 1.5. The other option for this would be to plug a 1 into f of x. So here, I'll do it over on this side, maybe in red here. We could plug 1 into f of x, get 1 over 1. Plus, we could plug in 1 to g of x, get 1 over 1 plus 1. And we'd end up with 1 plus 1/2, which is 1.5, or also equals our 3/2 over here. So pretty straightforward here with as far as adding things. See if we can get drilled down properly this time. There we go. Okay, so now we're going to do some multiplying. And remember our functions here. Sorry, I'll scroll back up so we can see them better. So we're going to multiply f of x and g of x. Literally the same idea again. We're going to have 1 over x times x over x plus 1. Hopefully remember, if we see the same thing at the top and the bottom, those are going to simplify to 1. So we will just get to 1 over x plus 1 for this answer. Okay. We're going to get to some domain things eventually. Here, think about that we can't really have x be equal to -1, so that may be something that's asked about. In a variety of ways, maybe in interval notation, maybe in something else, but we definitely can't have x equal to -1. So then if we do f times g of 2, then we're just plugging 2 in again. So same idea as up above. If we plug in 2, we're just going to get 1 over 2 plus 1, or 1/3. Okay. Last one, dividing. And I will scroll down a little bit this time just because we're running out of space. So hopefully we can remember what they are from up above, or you have your sheet in front of you. So if we go ahead and divide, we're going to have 1, actually I'm going to write it over here. It's going to be kind of crazy off the side. 1 over x divided by x over x plus 1. Now, I hope we remember that dividing is the same as multiplying by the reciprocal. So if we want to make this look a lot better really fast, we're going to have 1 over x times x plus 1 over x. And if I go ahead and multiply straight across, then I'm going to have x plus 1 over x squared. Again, nothing to simplify. That's our final answer. If we wanted to talk about domain of this, then same kind of issue as before. Like, what number can I not have in the denominator? Well, I obviously can't have 0. Okay, so since I can't have 0, I would want to say something about all real numbers except x can't be 0. So maybe something like this. Or, remember, we've been working really hard on interval notation. So let's talk about how do we do this if we've got interval notation and we just want to exclude the one thing. So negative infinity all the way to 0, but not including 0. And you use a little union symbol. It looks like a U. And then 0 all the way to positive infinity. Hopefully that shows up. There we go. Okay, that's a way to say that same idea, everything except 0 in interval notation. Okay, next thing, compositions. So remember the way to say this is f of g of 4. It's not multiplication, it's plugging g into f. So if you remember from the past, you start here with the g of 4. You do that, you get an answer, you plug it in. So in other words, another way to write this would be f of g of 4 like that. So again, do g of 4 first. If we go back and look at what g is, if we plug in 4, we're going to get 4 over 4 plus 1. So we're going to get 4/5 for g of 4. And then we need to plug 4/5 into f. Remember, f was 1 over x. So we've got 1 over 4/5. If I multiply it by the reciprocal, my final answer here will be 5/4. So again, one more time, we do the g of 4 first. Whatever answer we get there, we plug into f. Okay, same idea on the next one then. F of g of negative 1. So I'm going to do the g of negative 1 part first. If I plug that in properly, then, what was it again? G of x is x over x plus 1. So we're going to have negative 1 over negative 1 plus 1. So we get negative 1 over 0. Well, we can't even divide by 0. So since that's undefined, we can't even keep going, can't even plug it in. So overall, our answer for this would have to be undefined. In WebAssign, a lot of times it'll say does not exist, and you have to type in DNE. But one of those two things, undefined, doesn't exist, kind of the same idea. Okay, let's move on and do another one that's slightly different. Same idea, though. We're going to go through all the same exact steps, just with a different function, just kind of to see different set of functions, just kind of see a little bit more. So here's a new f of x and g of x. So f of x is 1 over x, which it still was before, but now g of x is x plus 3. So when we go to add these, it'll look a little bit different then, because we still need to get a common denominator, but like, what is the common denominator this time? Remember, this is over 1, technically. So the common denominator is x. So let's multiply this one by x over x. And when we do all that, we're going to end up, when we distribute here, we'll get x squared plus 3x plus the 1 over there. So our final answer, if we kind of do some rearranging, x squared plus 3x plus 1 all over our common denominator of x. Okay. Again, we're having you plug in 1. So if we plug in 1 to that, it's just going to, like, I can just use that, or again, I can do them separately if it's easier, and it might be easier to do them separately this time. If I plug in 1 into f of x, I get 1 pretty quickly. If I plug into g of x, I get 4 pretty quickly. So I know overall my answer is 5. So it's like, okay, well, that's not so bad. If I plug it in over here into what I just found, we've got 1 squared plus 3 times 1 plus 1 over 1. Same thing, not too bad. We've got 1 plus 3 plus 1. Okay, ends up 5 over 1. So either way, we get 5 pretty quickly. Another multiplying problem. same stuff again. So when we're multiplying, we're just going to go ahead and write out 1 over x times x plus 3. We multiply straight across. The x plus 3 is over 1, so x plus 3 on the top. X times 1 will give us x in the bottom. Again, there's some domain things here we should talk about. We're going to talk about it down below for the division for sure. When we do f of g of 2, plug in 2 again. Again, you could plug it into both things up above, and since we already did that, oh, we did for 1 though, never mind. But if we plugged in 2, we'd get 1/2 times 5, so we get 5 halves. If we want to plug it in here, you can see you get the same exact thing of 5 halves. So either way, or 2.5 or 2.5, it's all the same. Division again. So remember, we're going to multiply by the reciprocal, so let's just start there. So 1 over x, instead of dividing by g, let's multiply by the reciprocal of g. Remember, x plus 3 is over 1, so we're going to have 1 over x plus 3. It's multiplication symbol right there. If I multiply straight across, I'll have 1 over, and I can either multiply it out or just leave it alone. Okay, it doesn't really make a difference if I have it written like this, x times x plus 3 over x squared plus 3x, same thing. And as far as the domain then, I think this way is easier to tell than the two things that will make this 0. So if you're like, okay, how is she getting this? Not sure. Set it equal to 0. So say, okay, x times x plus 3, set it equal to 0, because I can't have the denominator be 0. So think back to your zero product properties. X could be 0, x plus 3 could be 0. So here's a problem area. The other problem area is -3. Okay, those are plus signs. So there's my two problem areas. So it's everything except it can't equal 0 and -3. So I could say all reals x cannot equal 0 and -3. Again, you can do that in interval notation using that union symbol. Let's see where I can squeeze it in at. Maybe able to squeeze it in along the side. Let's see how fun this is. So I could do -infinity to -3 unioned with -3 to 0 unioned with 0 to infinity. That's the way you would actually write that in interval notation to say the same idea. F of g of 4, remember we talked about this over on the other problem. We're just going to do g of 4 first, and then we're going to go ahead and plug that into f. So if we do g of 4 here, that's just going to be 7. 4 plus 3 is 7. But then we're going to do f of 7. Okay, so the g of 4 equaled 7 because I plugged 4 in. Now I'm plugging that into f, and I'm going to end up with 1/7 then. Same thing for the next one, f of g of -1. So same idea to start out with. I'm going to go ahead and think through what g of -1 is. If I plug that back into g up above, -1 plus 3 is 2. Okay, that's this part. And then I'm going to do f of 2. So this time it's going to be 1/2. Okay, and some of you are probably wondering, like, can't I go the other way? Can't I plug g or f into g instead of g into f? And the answer is yes. So we do have that on these last couple of problems to think through. And I might add on a few bonus ones too, but f of g of x, now we're taking the whole thing and plugging it into the whole thing. Okay, and this is where it gets a little tricky. So I'm going to try to use some of the space down here at the bottom, I think. So on this one, we're taking g of x and we're plugging it into f of x. So I have to know what g of x is first. So g of x is x plus 3. Okay, so if g of x is x plus 3, and f of x, remember, is 1 over x. What we're saying is we're taking x plus 3 and we're plugging it in for x right here. We're taking g of x and we're plugging it in for f of x. If you think about what we did up above, when we knew we had f of 2, we plugged it in for the x value. So now we're saying we're taking all that. So in the end, I'm writing f of x exactly like it was, except for instead of where I see the x, I'm taking everything from up here. So x plus 3. And that is our answer to this one.